My name's Matt Hatcher. I'm the shop manager here. Any of the custom commissions that come in that are out of wood or hopefully in the future going to be out of metal, I do things like that. I keep the place hopefully running smoothly with the help of Casey here and Alex Bandar. If you haven't met him, Alex is the creator of the Columbus Idea Foundry. He's here a lot. Very smart dude. But I teach woodworking classes. I teach basic 3D modeling classes with Google SketchUp. Very easy to use introductory program, free program also if you ever want to get into 3D modeling. Highly recommend that. Very easy to use. And now I'm taking over the CNC classes. CNC stands for Computer Numerically Controlled. In essence, that is just a gigantic woodworking machine, kind of like a woodworking robot, if you will. But I am going to go ahead and show you a picture down here. Our CNC looks just like, I have a picture on there, I think it's back here. There it is, yeah. This is the picture of our actual machine. So it's a full 4 foot by 8 foot. 4 foot is the Y direction. I'll definitely get into this more, so if you don't get anything, if you're a little over your head right now, don't worry, I'll get into detail of what all this stuff means. X is the long direction, so 4 foot in the Y, 8 foot in the X, and it also goes up and down in the Z. The max Z depth is 6 inches. That, of course, all depends on the bit that you have in there. If you can find a 6-inch cutter, you can cut 6 inches deep. But that's definitely a specialty bit. Most bits, and when I say bit, I mean a router bit, I mean an end mill. They're all called a bunch of different things, and that's kind of the first picture I had showed up here on this is just Google Images. These are all router bits. These are kind of considered end mills, these spiral fluted doohickeys up here. But I just call them all router bits. The biggest difference between, we're probably all used to like just drill bits. Drill bit kind of looks like this guy down here. It's kind of got the spiral flute, but a drill bit actually only cuts at the very tip. Router bit actually has sharpened edges all along the edge, so it can cut in all different directions, which you absolutely have to have when you're using a CNC machine. So I am going to get into a little basic presentation. I thought I had it up right down here. I'm going to back up a little bit. There we go. So once again, this class is the basic orientation for our ShopBot CNC. CNC computer numerically controlled. The ShopBot is actually the name brand of the CNC machine we use. The ShopBot came around about 15, 16, 17 years ago or so. CNC machines have been around for a long time. They've been ridiculously expensive. They didn't become kind of usable to hobbyists up until kind of ShopBot came around, and they became much, much cheaper. Before ShopBot, they were $250,000 machines, $500,000 machines, and they were just for production. Those are the only people that could afford it, and they were for just knocking out parts. The guy who created ShopBot, he started off as a doctor. He was building boats in his spare time. So he was building all the curved frames, the actual forms that he would bend the spars of the boat around. He was doing all these by hand. And he had seen CNC machines before. And CNC is fantastic for doing those curved lines like that. It can do anything. It can do perfect square, but it just excels at curved lines. Because it just does it automatically. You don't have to do anything by hand. And so he knew about CNC machines, and he was like, good Lord, CNC machine would really help me out with this. But everybody he contacted was like, you're too small, you're small fry. It's going to be a minimum, $50,000 order to cut your parts. And he saw a CNC machine. And, let's go back to that picture of our CNC machine. And you know what? It's a very simple machine when you think about it. If you know what a plotter is, a plotter or like your inkjet printer at home, it's just got a carriage that goes left and right. This kind of does the same thing. This guy right here, that's the actual machine. That's the router that has the bit. It just spins it. That's it. But then it's on a carriage that goes left and right, and it also rides on these rails that travels this way. So it's kind of like a big plotter, but instead of an ink pen, it just holds a router bit. So it's very simple. And he's like, it's why is it so expensive? Why isn't there a cheaper version? And he was a smart dude, so he came up with a plan to make a easier to use, much cheaper version of this. Of course, he had to do a little bit on the software side too. But he eventually started just selling plans on the internet, and people loved it. He just sold you the plans and the material file, or the material part list, where you can just go to the store and order whatever you needed, the extruded aluminum or the wood, and so on, the stepper motors and all that good stuff. And then he would sell the program that would control it, and the people were like, that's great, thank you, but start selling me parts. I don't want all this, you know. And so he started selling parts, and eventually people were like, you know what, thanks, but just sell me the entire thing. So sure enough, he started selling the entire thing. That thing comes in 3 big boxes. All the parts come with it. You put in your own router if you want to. It's the exact same router that you can buy at any woodworking store. We have the same exact router, just in our normal woodworking router table. And he eventually became a huge business, and he quit his day job, and he's been doing this ever since. And now it's opened it up dramatically to the DIY maker, amateur kind of person. So now there's, for $200 a month, if you want to have one of these in your garage, you can have it in your garage. And there's thousands of people across the country now have a big, awesome machine like this that can do so many things in their garage, doing some awesome stuff. And if you didn't see the pictures I was showing earlier, let's see here. These are just some examples. Every one of these are pictures that, or are examples of things you can cut on our machine. There we go. So these are carvings. Obviously, these are going to take a lot longer than just a simple little profile. But if you want, this is just layered plywood. Cut all these profiles out of plywood and glue them all together. Once again, CNC just excels at curvature like this. And then some more 3D stuff. And this whole style of kind of furniture made out of sheet goods has become very popular since this ShopBot has come around, because 4-foot by 8-foot sheets of plywood are readily available in every part of the country. So people have really come up with some cool designs on to create furniture out of relatively cheap and easily available materials, such as this.
Is it still recording?
Yeah. Yep. Let's see here. And once again, just some simple stuff that looks extreme, and it would be if you didn't have a CNC machine. Something like this would take forever. But with the CNC machine, the hardest part is just designing this in the CAD program you have. Once you have it designed in the CAD program, it's so easy. So yeah. So this class, once again, is the basic class. All we're going to be talking about is 2D and something called 2.5D. And that's two-dimensional, if you don't know what that D stands for. So this is definitely going to be basic, but once you take this class, and if you're a member, you will be able to use our CNC machine on your own without any supervision. So I am going to go ahead and start this presentation. So Columbus Idea Foundry, if you don't know what we are, we're a community workshop. Anybody can come in and become a member. And once you're checked out on a tool, like this class is now going to check you out on our CNC machine. Once you've been checked out on a workstation, you can come in and use that workstation like you owned it. Already talked about this, what a CNC and ShopBot is. The different materials you can cut, we'll get into it. We'll definitely talk about the differences between 2D, 2.5D, and 3D. One of the biggest things you're going to need to understand is the difference between a raster image and a vector image. Raster and bitmap are considered the same thing. They're slightly different, but you have to know the difference between a raster and a vector image. I already told you, CNC stands for computer numerically controlled. There's all kinds of different... How's it going, man?
Pretty good.
Absolutely. What's your name?
Braden.
Braden. All right, cool.
Somewhere around there.
What's that?
Somewhere around there.
Yeah, I got you. So if you know, like the ShopBot, ZenBot, Bridgeports, 3D printers, laser cutters, all of those things kind of are the same thing. They have a cutter of some sort on different rails that travel in the X, Y, and sometimes Z. So they're all kind of similar. So if you've taken our laser cutting class, which if you haven't, I highly recommend, you'll be surprised of how much overlap the two different things have, even though the laser cutter, the biggest part you can cut is 12 inches by 24 inches. But still, there's a lot of overlap. And that's the only thing about these things. It just allows precise, repetitive control over different fabrication tools, which is fantastic. Oh, it stopped?
I don't know if it stopped.
Oh, you're right. So our CNC machine, our ShopBot CNC, is a 3-axis machine, which means it can only go in X, Y, and Z. There are different 4-axis machines, 5-axis machines. That just means it's the exact same thing. The cutter head will move in the X, Y, and Z, but then the table might actually rotate. And then actually the actual cutter head might rotate also instead of just moving up and down, left and right. Those are much more expensive machines, and in all honesty, it's kind of for specialized things. If we can, afford $250,000 machine, it'd be awesome to have. But our CNC machine is only $20,000, which is much more manageable for us. So I've already mentioned the X is the long part of the table, which is a full 8 feet. Y is the short end at 4 feet, and then the max Z depth, which turns that into 3D, is only 6 inches. But once again, that all depends on your bit. Most bits, router bits, come 2.5 inches long. The longest I've seen before you get into specialty bits are kind of 4 inches. So if you're looking to do anything over 4 inches with like 3-dimensional carving, you'll have to probably order a special bit. The IPS, the up to 4 IPS cut speed, that's inches per second. That's typically how we talk about movement speed when it comes to our ShopBot. You can definitely do inches per minute, millimeters per minute. There's a drop-down menu that allows you to change that, but we work in inches per second. And 4 is the max, and that is that's with wood. 90% of the time we're usually cutting through solid wood or plywood of some kind. If you're cutting through aluminum, it's going to be much, much smaller. We're talking 1 inch per second if you're doing aluminum. If you're cutting through foam, it might be a little quicker. It just all depends if you're doing 2D or 3D cuts. So 4 inches is just max. The collets, which I'll show you once the last half of this class, I will actually show you what a collet is. That's what actually holds the different router bits into the on the router. So it's the shank of a router bit. You can get them in 1/4 inch, 1/8 inch, 1/2 inch. So I'll definitely show you what those are. And on our machine, it just shows you that 0.005 inch of resolution is it's extremely high resolution. The different materials you can cut, obviously wood, plastic, foam, vinyl. Ignore this steel down here. You cannot, so I'm going to, go backwards. You cannot cut steel on our CNC machine. You would have to have a plasma cutter CNC machine or something like that, or just a much better router than we have. So any soft metal, we cut aluminum all the time. Brass is soft, so I don't know if we've ever cut a brass, but you definitely could. So anything but steel. We've had people cut stone, we've had people cut plaster, so lots of different things you can cut. So yes, this class is covering 2D and 2.5D. I'll briefly talk about 3D, but I'm not going to show you how to do that. That is definitely much more involved. But 2D, it's very simple. Very self-explanatory probably. The machine just moves in the X and Y. It doesn't move in the Z. The Z is up and down. That's what will create the 3D movement. So 2D is purely X and Y. So yeah, while it's moving in the X and Y, the Z just stays constant. And obviously, like if I had down here this little blue rectangle, this is an example of maybe like a cabinet door or something that you would cut out of a piece of wood, and that would be a profile cut. If I'm just going to take the router bit and go on the outside of that line, I'm cutting out the profile of that shape. That's exactly what you're going to use a 2D toolpath for. Or if I wanted the tool to be on the inside of that line, that's what a pocket cut is for. And once again, I will definitely get into this a little bit more. You can only use vector lines. And once again, I'm going to talk about the difference between what a raster is and what a vector is. You have to know the difference. All these tools, the CNC machine, the laser cutter, they have to have a vector. You can sometimes you can start with a raster, but you will eventually have to turn that into a vector. And that's all it is. That's why it likes a vector, because a vector is a single line. And now that the tool is able to see that single line and use it as a toolpath. 2.5D, think of that as a calligraphy brush. A calligraphy, like if it's got a really soft tip where you can, as you're writing, you can put a little pressure down and make a fatter line and make a skinnier line. 2.5D, in all honesty, is mainly for sign making. There's probably other ways to use 2.5D, but in my experience, it's almost always going to be just for making signage, for making the letters on signage, which is exactly what we're going to do. We're going to do a little bit of that. We're going to do a 2D profile cut, and then we're going to do some letters inside that shape that we're going to cut out with a 2.5D toolpath, which will give us thin lines and fatter lines and things like that. And typically with the sign making, you're going to use a V-tipped bit, which I'll show you. We'll go over different straight cutters and V-tip bits and round over bits and things like that. Yeah, so you need a 2D file for this, and it needs to be hollow, and I'll show you exactly what I mean by hollow when you do this. So next slide. And 3D, as you can imagine, it moves in the X and Y, and the Z plunges in and out at different depths on the fly as it's moving in the X and Y. And our machine can definitely do that, but once again, it just is definitely a little more involved, and it requires, the hardest part is actually designing the 3D model. If you can design a 3D model, it's not really, after this class, it won't be that much more difficult to do a 3D toolpath. It just.
Are you offering a class or anything to give the depth of that?
I haven't yet. Because that's the problem with it. That's the problem with teaching a class on this. If I had like an interview with you for 10 minutes and found out that I didn't also have to teach 3D modeling, it might be okay. But if I have to teach you the basics of 3D modeling, that's an entire 6-hour class by itself, and then turning it over here. So it just all depends, you know.
So would it make sense to maybe take the Google Sketch class that you were talking about before, and then go into this?
Yeah, definitely, but still, just that Google SketchUp class, because that SketchUp class isn't for making 3D models to cut out on the CNC machine. There's so much more complexity when you get into 3D. You definitely can. That's exactly how I use SketchUp. I will create a piece of furniture and just model it, just to scale down, get the proportions down, but then I will actually take those parts, and if I need to cut them on the CNC machine within SketchUp, you can lay them out and use that as your lines to then import into the other program you need to create the toolpaths. So yeah, there's definitely interconnection there, but there's a lot of different steps along the path that you need to know. And yeah, when you're doing 3D, you can use all kinds of different bits. You can use a flat bit or a round bit or a V-bit. I'll get into that a little bit more. And it's absolutely 100% much longer to do. I did a very small little smiley face. I'll show it to you when it's over in my studio. Just about maybe 6 inches in diameter and only an inch deep. But it was a full curved surface, and I did it with a tiny little bit where the tip of the bit was a 1/16 of an inch wide, but it was rounded on the bottom. That's what you use for carving. It took an hour and a half to do that. So just keep in mind, if you're doing anything 3-dimensionally, it's going to take a very long time. And of course, it requires a full 3D CAD file, or not just CAD file, a 3D file. So now we're going to start talking about the difference between a vector and a raster. If you already know the difference, bear with me. It is definitely an important concept. Does anybody here not know the difference? Do you know, if I said, what's the difference between a raster and a vector, you can explain it logically to me? Yeah?
Yes.
Okay, cool. Well, I'll go over it briefly, but a raster bitmap image is the normal photograph, a lifelike photograph that you're used to, like this picture right here. It's not, well, it's a normal picture, and it's made up of pixels. So if I zoomed in on this, you would eventually start seeing pixels. It would get all blurry, just like this. So you zoom in a little bit, and then you start seeing those pixels. A machine it's not smart enough nowadays to determine that this little shade of brown is, that's differentiating it from the eye to the nose here. The machine does not know that. Maybe in a little while you'll be able to import a raster image and it'll do a better job of this, but the machine just does not know which pixels to use. Even on the outside profile over here, it doesn't know which pixels to use. And zoom in even further, it's a pain. So a bitmap is not scalable. So once again, that was just me scaling the image up over and over again. It eventually will become very blurry. And once again, the toolpath, the machine, the software is not smart enough to know which pixels to use as a toolpath. And just remember, that's exactly what we're going for. We're creating a digital shape, and we want a machine to cut that shape out. So we need to create a toolpath. So we need a line, we need something that we can select and tell it to use a 1/4" bit or a 1/2" bit or carve it. We need something. So with a bitmap image, a raster image, you can't do that. And most of the time, a toolpath is generated from a CAD file. CAD is computer-aided design or computer-aided drafting, and there's dozens upon hundreds of CAD software packages. And there's 3D, there's 2D, there's all kinds of stuff. There's free ones and there's really, really expensive ones. So you can use a CAD program if you already have one, or you can just use there's like just Adobe Illustrator is another program that you can make your shapes, your toolpaths out. You can make the shapes, but then you got to take those shapes into a different package. That's where the CAM comes in, computer-aided manufacturing. You need both programs when you're doing this. So you can use a CAD program or a vector software package to create easy toolpaths. Or if you do have a bitmap image, you can convert it into a vector. And we will go over that briefly, but once again, I'll probably say this a couple times, it's always best just to start with a vector. And if you don't know, if you've never made vectors, I'm not going to lie, it's a learning curve. It's going to take you a minute or 100, or it's going to take you a while, but stick with it because it goes across so many different kinds of these tools with a laser cutter and with 3D printing and things like that. In this day and age, you really have to wrap your head around vectors because it makes all of these tools much easier. And it's easier than it was nowadays. I remember in high school when I first clicked on the ink pen tool or the pen tool and started drawing with it. Usually people never touch it again because it's not intuitive at all. It's easier nowadays, but really stick with vectors because it helps out down the line.
You're at 12 minutes on this one.
Oh, geez. So a vector can be created from scratch using a CAD package or a vector software package. So once again, I don't use, well, I guess you can consider Google SketchUp a CAD package, even though it's pretty basic. I typically make most of my vectors, and I'm an Adobe Illustrator fan myself. But there's also Inkscape is the free open source version of Adobe Illustrator, and it is very powerful. Just because it's free and open source, don't let that fool you. It is an extremely powerful program. It definitely has a learning curve just with any of these. It has lots of different features to wrap your head around with. But if you ever want to look at any of these, whether it's Illustrator or Google SketchUp or Inkscape, just Google Inkscape tutorials for beginners, any of those things, and you'll get hours upon hours of video tutorials how to get you started. And lynda.com, Lynda, lynda.com, fantastic websites, $20 a month. Everything very like the highest quality video tutorials that you can find on all of these programs, in addition to just the creative process, starting a business, managing a business, just so many different things. Lynda.com, it'll change you. It's a wonderful website. I've been using it for years. Couldn't recommend it high enough. So here, once again, you can spend tons of money. Like SolidWorks is a very high-end CAD package. If you can get in there and use it, you can do some very, very amazing things. but just keep in mind there was a nice learning curve up there. So, and once again, you can convert a bitmap image into a vector. There's lots of different steps to that, and I'll briefly show it to you if you want to use it. But once again, just start with a vector. Makes things so much easier. I'll go over that a little bit more. And ignore this. That's it. So we are going to get into the actual program that we use to create the toolpaths. This will be considered the CAM program. There's CAD, which you design in, and there's CAM, which allows you to create the manufacturing steps, create the toolpaths. So the program we use is called PartWorks. PartWorks comes with ShopBot. PartWorks is not free unless you buy a ShopBot. But here at this Columbus Idea Foundry, if you become a member, we have a couple different machines, a couple different computers that have PartWorks on it. So once you become a member, you are more than welcome to come in here and use our tool, use the PartWorks computers anytime you want. Your $35 a month membership fee covers that. So keep that in mind. It's called PartWorks, and it's actually on this machine right here. There's this machine. It's just I push it to the side right now so I can have some room. But also the computer that's actually on this ShopBot has PartWorks also. I am going to use a program called Aspire. Vectric Aspire, same exact company. Don't let the name fool you. The interfaces are exactly the same. So you're looking for, if you come in here on the computers, you're looking for PartWorks. But I'm going to use Aspire here. Once again, the name is the only thing that's different. Everything else looks exactly the same. This is going to pop up, and everything is exactly the same once again. And you're going to go ahead and go over here to the left and create a new file, or open an existing file if you've been working with something up until now. So we're going to create a file, and you're going to get this screen right here. And this is, as you see in the upper left-hand corner, this is the job setup menu. It'll always pop up. It wants to know what piece of material, what is the size of the material that you are going to put onto the CNC machine. So you kind of need to know that when you first start. If you're been cutting a bunch of pieces out of a full 4-foot by 8-foot sheet of plywood, those are the dimensions you're going to put up here under size. We are not. We are using, I'm going to do just a little simple sign, and I think it's 15 inches by 15 inches. So I'm just going to type those in. And it wants to know the thickness. The thickness I'm actually using is 1/2 inch. And you do want to measure your piece of wood. Just because you bought 3/4 inch plywood from Lowe's does not mean it's 3/4 inch. Believe me, it could be a full 1/16 inch off, and that will mess things up. So get a tape measure out, get some calipers out, and measure the thickness of your material, especially when you're doing something like this with a very accurate machine, because it can cause problems. I did measure it. It is right at 1/2 inch.
How accurate do you have to be on that?
There's a reason why you need to be accurate with the thickness.
Well, I mean, but how accurate?
If you're machining some aluminum ball bearing holder or something like that, very accurate. If I'm making overlay cabinet door out of plywood, not very accurate. It really, it just depends on if you're like seriously machining something or if you're just cutting out some simple wooden shapes. It's more accurate. The thickness isn't going to kill anything with that. The biggest thing with thickness, say if I had a 3/4 inch piece of plywood and I put it at I put 3/4 inch in here, but it was actually a 1/16 inch shorter. I've actually seen 3/4 inch plywood even less thick than that, like a full, like almost 1/8 inch. And if I put that in there and then put this onto my CNC machine and I zero it properly, it's actually going to cut through. It's going to think there's a 3/4 inch piece, but it's going to cut all the way through 1/8 inch through your piece. We have what's called a spoil board on our machine, so that's okay. It's okay to cut through your actual material into the spoil board. That's why the spoil board's there, and we're going to get into this. Don't worry if you don't understand this. But you don't want to gouge the spoil board. It's expensive. It's a pain in the butt to change. Once you get experienced with this, you will get to the point where you cut through your piece of wood, fully cut through your piece of wood, and you might not even be able to tell that it touched the spoil board. That's where you eventually want to end up at, just because it'll allow the spoil board to last much longer. So that's the biggest reason why you want to measure it, because you don't want to gouge out our spoil board. because I'm the one who has to replace it. Now, there's a couple things, very important things to keep in mind over here besides these very self-evident dimensions that you want to add in. The XY origin position. Sometimes when you start this program, especially if you on one of these machines that are here at the Columbus Idea Foundry, the XY origin is going to be somewhere else. And you want to make sure that it is bottom left. That is a very important option. What that tells you where 0, 0, 0, that's where the machine is going to be zeroed. And if you don't understand, let's go back to my picture, which is I think down here, of our machine. The farthest X, Y, Z, 0 position is going to be in this corner right over here. That's the farthest XY. You can tell the machine, which I'll show you, we're actually not going to zero. When I put my part up there, I'm going to zero it somewhere inside of it. But if I had a full 4-foot by 8-foot sheet of plywood, I would want to use as much as possible, so I would have to zero way in this corner. So bottom left over here is right there. If I went top right in this option, it would be down here. And it's not going to throw you any warnings. If you came over here and just clicked like, okay, got my dimensions, and came down here and clicked OK, and then laid out your files, laid out your parts, made your tool paths, and did everything like that, saved them all out, took it over to the CNC machine, and loaded up your first tool path, and you're like, fantastic, great. Even if you zeroed the machine over here, it thinks the program wants the 0 to be over here. So the first thing it's going to do is going to run way over here and try and run off the side of the machine over here. So, and it's not going to warn you. It's not going to do anything. It's just going to crash and make a bunch of nasty noises. So it is very important that until you know better, for whatever reason, I don't know if you want to go over there, make sure you know what you're doing, but make sure it's bottom left. And I say that because people come in and use this machine right here, use PartWorks to lay out their files, and it's, I don't know why, maybe it defaults with PartWorks to be in the center. Just make sure it's bottom left. And another very important thing, sometimes this use origin offset is clicked. You do not want it clicked. You want that to not be clicked. So sometimes that'll be clicked, and if it's clicked and it's set to 0, 0 like it is now, it's not going to hurt anything. That's no problem. But sometimes it's something weird like that. Don't ask me why. And I'm zooming out right now. Where's my actual screen at? See, I don't even know where it's at. And that's exactly what it's going to do. Now you said all this, fantastic, but for some reason you wanted X to be way the heck out there and there. And it's not going to throw you any warnings, and the exact same thing. It's going to, the machine, the head, as soon as you press play, when you get to the actual CNC machine, it's going to go off the table. It's not going to hurt anything, but it's going to hit the stops, and it's going to make a nasty noise, and you're going to be like, what the heck did I do? So just save yourself a lot of time and effort and headache, and make sure that's bottom left, and make sure use origin offset is unclicked. Oh, 10 minutes. You had a question?
Yeah. So the machine knows that it's like reaching its limit, right? Like it won't like try to go.
No. Some CNC machines, yes, they have nice electronic sensors that as soon as it hits that electronic switch, it'll stop. Ours does not have that. It has clamps bolted to the where the gears are, and it'll hit that, and it'll still try and hit it, so it'll make a nice pounding, nasty noise.
So you have to stop it.
You stop it, and I'll show you how to stop it. There's emergency stops, space bar on the machine out there. When the machine's running, space bar will stop the machine. So once again, just make sure origin position is bottom left, and use origin offset is unclicked. I can't tell you how many times and how many problems that has caused. Data scaling, I don't know what that means. Leave them unclicked. And units, if you like millimeters, click millimeters. But we're all Americans here, so we like inches. Modeling resolution doesn't matter. That's just all that is for just your view in PartWorks here. It has nothing to do with your actual output. So if your machine is running sluggish while you have your nice 3D model here, you might have to turn that down slow. In appearance, same thing. If you notice here on the two tabs, it has the new button, which is just because I haven't named my file, but it also has a 3D view. So if you click that 3D view, and I'm going to left click and drag, it actually has a three-dimensional view. So once you start putting stuff in here, you can actually, even if it's a 3D model, you can put a 3D model in here, and you can rotate around it and zoom in with my scroll wheel. And yeah, pan, which is just moving it left, right, up, and down. You have to hold the left mouse button and the right mouse button down at the same time. So that option is there, and that appearance drop down, that's if you want to change the appearance of that. It doesn't affect the output at all. If you just like the look of oak, or you can change it to that. That's all that does. I'm going to click over to my 2D view again. And then once that's all set, just click OK. And now you have it all set up. So we got all the different tools. These are kind of a lot of these tools you'll see in other different programs. It does have basic vector creation tools, like you can create a circle. You just click on it and then drag. You can create a circle. Or you can dial in exactly the radius or diameter of your circle if you want to, and the exact center point of that circle if you want to. And same thing with ovals, squares. And if you need to make a perfect square, just hold down the Shift key. Or I think it's actually different with this one. What is it? That's Control. Every other program in the world is Shift. This one is Control. Or, once again, you can dial it in perfectly with the dialog boxes over here. You can have nice radius corners if you want. And if I have my square still selected, so if I radiused the corners here with a 3-inch radius and pressed Apply, it should have done it. Radius external, Apply. Apply? Maybe it's not big enough. That's probably too big. How about 1 inch? There we go. Not real sure why I made a copy, but I can just select that first one I made and just press delete. So, and also the great thing is, if you decide, you know what, 1 inch is too big, I want half of an inch radius on that, you can go back into that dialog box, just the same shape. It was a square shape I started with, so select the square. We back out of that. Actually, you have to select the shape first. So select the shape, and then select the tool that created that shape, and then all the same options are there, and you can change that to whatever you want. So I can change that to 0.5, and it changes it on the fly like that. So you don't have to delete it and start over. And I can do the exact same thing if I wanted it exactly 5 inches by 5 inches. As long as I have my shape selected, it'll make the changes for me. And same thing with all these. I can just select that one, go back into my shape box, and do whatever I want here. I want 3 by 3 square. And press Apply, and it updates that shape on the fly. And the exact same thing with the circle. Just select the shape, go to my circle tool now, and I can do the exact same thing. Or put the center exactly at the origin. Not that I would ever want to do that, but just showing you that you can do it. And if you just want to free move it, you can just click it, and the little crosshairs changes, and then you can drag it around wherever you want to. And you might need to come over here to Edit Objects, and it's got the 3 different cursors. You might have to grab the Move, Scale, Rotate button, and now you can move it wherever you want. If you want to rotate it, if you just, as you can see with my cursor up here, if you just go hover it up in the corner, it'll change to a little rotate icon. Once you see that, it'll rotate. So I'm just going to press Control Z to undo that step. So very basic digital editing tools that you can use. That, you know, the vast majority, Adobe Photoshop, Illustrator, any design program you ever come across will have these basic editing shapes. So if you have a very basic item that you're going to be cutting out, you don't have to go to a separate program. You don't have to go to Adobe Illustrator. You don't have to go to a CAD program or Google SketchUp. You can create it right in here if you want to, but I'm not going to lie, it is very basic. You're not going to create some beautiful piece of furniture in here without a lot of headache. But for our purposes, since it is a very simple sign, we can use these. I'm going to delete these shapes. Just select them and press delete. And I am going to create just a simple, let's do an oval. Why not? I like ovals. So that looks good. I'm going to just close this, and once again, you can also use the actual arrow keys on your keyboard. Just make sure the shape is selected, and then I'm pressing the up arrow key, right arrow key, and as you can see, it moves it really small. If you hold down the shift key while you use the arrow keys, it moves it in bigger increments. And that's a little too big. I want to make sure my piece fits well within my piece of wood here, so I'm going to shrink it down a little bit. And to do that, I'm going to just select the Move, Scale, and Rotate tool. And as you can see, it's got this bounding box around it, which allows you to, select again, allows you to, where's my rotate? There, allows you to rotate it, allows you to move it, and it allows you to scale it. So that one tool allows you to do many different things. I'm going to press Control Z to go backwards in time a couple times till I'm right there again. I don't want to rotate it, I just want to go ahead and scale it in. And then move it to the center a little bit with my arrow keys. With all these different programs, there's 1,000 different ways to do each and every process, so whatever you like, go ahead and do it. So that looks good to me. And once again, if this was a project that you knew the exact dimensions, you can dial those in perfectly if you want to, but this is kind of just a freehand kind of design I'm doing just to demonstrate things. And now this outside profile, that's exactly what I'm going to do. I'm going to do a little profile cut. I'm going to cut this oval out of my rectangle piece of wood. But I want some writing on the inside. The writing I'm going to use, this has basic text tools in here too. Yep, right there. Draw text within a vector box. And what that means, this is the vector box up here. So I'm just going to type whatever you want. I'm going to type in ShopBot. And as you can see, most other programs, this is much more, it'll be much more professional looking. There's lots more options, lots more fonts. So this is very basic, but if you can get away with it, fantastic. I'm going to go down here to a little, how about, where's old Helvetica? Everybody likes Helvetica. Fix it up. Do I have Helvetica? Oh my god, no Helvetica. How about Times New Roman? And there's lots of different options. You can bold it, center it, do whatever you want. The exact bounding boxes, my outside dimension was 15 by 15, so it automatically put that in there. It thinks that's what I want. It's not what I want, but I'm going to leave it. I'm going to scale it manually once it goes on there. So you can mess with these options if you want to, but I'm just going to press apply. And as you can see, it made it real big for me. I don't want it that big. I want it to fit within my oval, so I'm going to go ahead and close out of this dialog box. I want to go to my scale tool, so I'm going to click that. And now I'm going to scale it down. But I want to scale it, I like how it's nice in the center there. I want to keep it in the center. If I just grab this, it uses the bottom left here as kind of the pivot point. I don't want that. I'm going to press Control Z. Keyboard shortcut is once I grab this, I can bring it in, but then I'm going to hold down the Alt key, or is it the Control key, or is it the Shift key? There it is. It's one of those keys. It's the Shift key, actually. Holding down the Shift key puts it in the center, so now I can scale it down perfectly in the center, and then release it, and I got my my little logo there. And just use my arrow keys to position it a little bit better if I want to. So that looks good to me. If I ever need it to use a guide ruler or something like there, if I really wanted to position it perfectly, I can pull guide rulers out very easily. Just, I click in here, drag, click and drag. Whoops. So, why isn't it doing it? that's weird. I must have an option turned off. Typically, you can just drag a ruler right out, put it wherever you want. Oh well. It must be. I don't know why I would turn them off. Huh. Very strange. But I don't need them. But once again, that's the first time I've ever seen them not working. So I must have some weird option turned off. I might have to reset my defaults after this.
What about just using the regular arrow?
Oh, that might be right. You're absolutely right. There you go. That's a smart guy. So yeah, that's very strange and shouldn't do that. I don't understand why, but the move, scale, rotate, cursor doesn't allow you to do it. If you need to put one out, use the select mode arrow. Select mode, that's all that does. You can't do anything. I can't rotate, scale, move it. It just allows you to select things. So if you need to move, have some guide rulers. These guide rulers, you can't turn those into toolpaths. Those are there. Those are invisible once you get your toolpath selection. Those are there just to help you line things up and makes things proportional and things like that. If you need to get rid of them, just right-click and press delete or select delete. So this is very, very basic, but sign making on the ShopBot is wonderful. It's fantastic, but it is actually surprisingly easy to do. So we have this. It's very easy. We have our shapes now. I got my outside profile that I'm going to fully cut out, and then I have my inside lettering that is just going to be etched onto the top. So that's all I want to do with this. Obviously, we can get as crazy as we want it with this, but for this class, this is good enough. So I have created my design. I have my shapes. But now I need to take those shapes, and I need to make the toolpaths. Do all that within the same program. As you can see in the upper right-hand corner, there's a little tab called Toolpaths. You can just click that, or it comes out. There's a keyboard shortcut I highly recommend everybody to use. The F11 and F12 key. F11, if I press it right now, does nothing because I'm already in the drawing tab. But F12 is the toolpath. So if I press F12, it'll switch them out. If I press 11, it'll go back to my drawing tab. It's actually really handy. So F12 will bring up the toolpaths. And now this is where the machine interfaces with the program and says, this is the bit I want to use, this is the speed I want to use, this is the depth I want to use. This is the important part. So the very first button or tool you need to use up here is upper left hand corner, setup material and rapid, what did it say? Rapid gaps. So click on that. It should have imported the vast majority of stuff from, I'm going to click over here in the drawing tab. When we put in the job dimensions and the thickness of material, it should have put all that stuff over here. And if you ever need to go back in, if you like, oh my god, my piece was actually 20 inches by 20 inches, and you need to change that, you can go back over to that. I'm going to press F11 to get back to my drawing tab. This button right here, set job dimensions and origin. You can do this anytime you want, even if you have 1,000 different little shapes on here. You can change this whenever you want to. So I can just type in 20 by 20, and all that does, it doesn't scale my shapes, it doesn't do anything, it just changes the piece of wood that I have. I'm going to actually leave it at 15 by 15. And go back to my toolpaths. And so as you see, it knew that my material is 1/2 of an inch. And that should be the only thing you need to worry about. This over here, the little radio buttons here, this is very important. I recommend you pick one and learn to use it, and then don't mess with it again until there's a reason for it. But there are people that use our CNC machine that like to have the Z0 set to the bottom of their material. And this shape here, this piece of wood, that is, think of that, that is the piece of material that you are going to cut. That's the piece of material you're going to put on top of our ShopBot. So you can zero, that means when we go to the machine, we have to put our router bit into the machine, and then we have to tell the machine where our 0 is going to be. We have to do that every single time. You can zero it to the bottom of the material, which means to the spoil board, to the top of the actual machine, or you can mount your material onto the spoil board and zero it to the top of your piece of wood. That's what I like to do. I like to put my material onto it, I like to screw it down, and I like to zero it to the top of my piece of wood that I'm cutting. And that's how I'm going to show you to do it. But you don't want to, if you have it, once again I'm going to press F11, if I can, to go to my drawing tab, and you have that same exact box here. And it'll change, it'll go, like if I change it here and press OK and go back over there, it'll update it. But just don't willy-nilly pick one of these, because if I click down here, but then went to the machine and zeroed to the top of my material, the first thing it's going to do, it's going to go right through my piece of material, and it's going to then go even deeper, thinking that's the depth of my cut. So the bottom, technically, if you learn how to do it, it's a little better. Only thing better I mean by that is you're going to save your spoil board a little bit. Cutting on the top is definitely safer, but you do have to be a little more careful dialing in the thickness of your material. So leave the zero to the top until you know better. And that's exactly how I'm going to teach you, and that's exactly how I use it. So don't think it's just a bad way to do it. So press F12 again to go back to my toolpaths and leave it up there. I'm going to zero to the top of my material. My material is 1/2 inch thick, so I'm going to leave that. Model, position, and material. This is for 3D modeling. We're going to leave that. You shouldn't have to mess with that at all. Just zero everything out if it helps you sleep better. The rapid Z-gaps above material, this does matter. For our purposes, 0.2 inches is fantastic. All that means is as our router is moving around and not cutting, it's just moving from point to point, that's how high above the material we want it to be. I've actually put full sheets of plywood, crappy plywood, on our machine and left that there, and it was really bowed in the center. It was actually bowed up like 1/2 inch above the center, and the machine doesn't know that, so it's just going from point A to point B, and if it's bowed up in the center, it's going to go right through there. So if you have a really bowed piece of wood, you might want to up that clearance here to 1 inch, and it's not going to hurt anything. I can put this at 2 inches if I wanted to. It's just going to save you seconds with the cutter head moving up and down that it doesn't need to. And if you have a bunch of parts on a full 4 by 8 sheet, it could amount to 2, 3, 4, 5, 10 minutes. It just all depends. But for our purposes, it would save 5 seconds if that. But 0.5 is typically a very safe clearance in the Z1 and Z2. And if you ever have any, there's typically a little picture over here that'll kind of help guide you in what those actually mean. The home start position, when we zero the machine, that's going to be the home. So if I changed my Z to 1, and when we go over to the CNC machine and I tell it to go home, there's a little command, which I always do, just to make, it's kind of like the last step I do to make sure that I zeroed my machine properly. I'm going to tell it to jog home, and it's going to jog. Where's my picture? My machine. It's going to, if it's anywhere else, it'll go home if I zeroed it to the X and Y, and it'll go 1 inch above my material. And I'll just visually inspect it to make sure it's not 3 inches above my material or right on top of my material. That's kind of my last check to be like, okay, I screwed something up. So I usually leave it at just 1/2 inch. I'm okay with that. But once again, I'm going to go back in there. If I would have left this at 0, or put that at 0 and had my Z zeroed being on the top and jogged home, the router bit's going to be sitting directly on top of my piece of wood, and it's probably not a good thing. You might scratch the wood. With the router bit not spinning, it cause all kinds of problems. So you never want that to be 0. Just to illustrate what that means. So press OK. That's kind of setting up the material. Fantastic. We just want to make sure, the vast majority of the time, this is going to be just, you're just going to look and be like, oh, okay, that looks good. I just wanted to explain things a little more, but the next time you do this, you're probably not going to have to think so hard about it. So then we have these different tool paths. And there's 2 or 3 that you're going to use a lot. The rest of them you're not going to use much at all, if ever. The 2 or 3 that you're going to use a ton are the profile toolpath, pocket toolpath, and 1 or 2 of these engraving toolpaths. There's the quick engrave toolpath, and there's the V-carve toolpath. We are going to use the V-carve toolpath. I am going to... So the first thing we're going to do is, it doesn't matter which we do first. I can select my text and do the V-carve toolpath, or I can select my outside profile vector and do that vector profile. It doesn't matter which one I set up first. And I'll explain a little later why that doesn't matter. When we get to the machine and actually cut this, it's going to matter which one we load up first. But for this purposes, it doesn't matter. We can start wherever we want. So I'm going to do the outside toolpath first. And once again, all I'm going to be doing once we go on the machine, I'm just going to be cutting this piece out. I'm just going to be using a 1/4 inch bit. I'm going to go down a couple times. Go down, since I just have 1/2 inch material, I'm going to do it in 2 passes. First pass is going to plunge down, 1/4 inch down into it, and then move around the object. And once it gets to the top again, it's going to plunge all the way down through it, and then do 1 more pass. So the first thing you need to do to create that profile toolpath is select the vector you want. If I had a bigger piece of wood and I was making 5 of these signs, I can select all 5 of these outside profiles and do them all at the exact same time. If it's the same kind of toolpath, you can select 100 different shapes, and it will do them all in one file, just one part file. You're not going to have to load up 1 part file per piece. It's the same toolpath, go ahead and select them all. But since we just have 1 shape, I'm just going to select the one. I'm going to click the profile toolpath, and then we got all kinds of stuff. The start depth, you always just start from the top, from the bottom, and it shows you here on the little left what the start depth and the cut depth actually are. You will never want your start depth to be anything other than 0 unless you know what you're doing. I did it once on a 3D carving, but you're always going to want to start at 0, which is going to be at the top of your piece of wood. So until you know better, that's always going to be 0. The cut depth, since the last piece of wood I cut using this program was plywood, it's saved it as 0.78. I wanted to cut through, it was actually my actual material was 3/4 of an inch, 0.75, but I wanted to cut fully through it, so I made it a little thicker. Our material is 1/2 of an inch, so I don't want 0.78. That means I would cut all the way through my piece of wood and then full 1/4 inch past it, and I don't want that. I just want to go barely past the thickness of my wood. So I'm going to do, since I know my piece of wood is almost exactly 0.5, I'm going to do 0.502. Nope, that's way too less. So just 0.512. There's no, you'll just get a feel for it. That's probably even a little too much. I'm just going to do 0.51. So I'm going to go I'm going to cut just a little bit past my material. And now I'm going to select my tool. I actually want a 1/4 inch end mill, but I'm going to go ahead and I'm going to edit it just to make sure my settings for that bit are correct, which you're going to have to do every time. So I'm going to press edit, and it has my 1/4 inch bit in there, which is fantastic. That's what I want. Verify that the diameter is actually 0.25, which is what I want. The pass depth means nothing. Pass depth is very important. The step over means nothing to us right now. Pass depth is for profile cuts. I'll explain more about this. Step over is solely for carving, 3D carving, and pocket cuts. I'll explain that here in a minute. So pass depth is important. Since I want to do 2 passes of this at a 1/4 inch deep each time, that's my pass depth, that 1/4 inch. If I wanted to do this in 1 pass, my pass depth would be 0.51. So 0.51 pass depth would do it in 1 cut. 0.25 is going to do it in 2 cuts. Actually, I'm going to have to go a little bit above 0.25 to do it in two cuts, since my material is actually, it thinks my material is 0.51. So I'm going to do 0.26, and why it's at 0.78, there's actually a special bit that you can use to cut 3/4 inch plywood in 1 pass. So that's definitely possible, but we're not using that bit. So we're going to use a normal router bit, and we're going to do it in 2 passes. So I'm going to change my pass depth to just 0.26, so slightly over 1/4 of an inch. And once again, step over does not mean anything for profile cuts. That'll be for pocket cuts, which I will explain, so just ignore that for now. Spindle speed is another thing that you can ignore forever on this machine. Some machines, some CNC machines, can actually read the spindle speed that you want, and it will change the spindle speed to whatever you want. Our machine does not do that. It is not that smart. It actually has 5 or 6 manual adjustments directly on the router that changes the spindle speed. So you can change this to whatever you want. It does not matter. And once again, that is just on our machine. If you go to a nicer, more expensive machine, you will be able to dial this in a little bit better. Feed rate, definitely important. And remember, we work in inches per second. You can change this to whatever you want. Just keep in mind, I only know inches per second. I would have to do math to figure it out otherwise, and I don't like doing math. So inches per second. And for wood of any kind, anywhere between 2 and 3 inches per second, you're safe. Don't worry about dialing it in perfect to the nearest thousandths of an inch. Anywhere between there, it's going to be okay. And if you have any questions about these, you can always Google it, or you can ask me or anybody walking around that knows anything about the CNC machine. You can be like, hey, I'm cutting out this oak. I'm going down 1/2 of an inch. Is 3 inches per second good? Or, we'll dial it in a little bit better for you. But that's a long conversation. Spindle speed versus feed rate versus the bit you're using versus the material. It all changes. But don't let that confuse you, and don't let that scare you away. There's a wide range that you'll be safe. So we're going to leave that at 2.5. That's fine. All that means is that's how fast the router is actually moving while it's cutting. That's the feed rate. So that definitely is important. If I went too fast, if I bump this up to 5 inches per second, it will try to cut 5 inches per second. But our machine is just not powerful enough. At 1/4 of an inch through the plywood that we're cutting, in all honesty, it might be okay. But if I had a piece of oak up there, no, it's going to knock the X and Y and Z out of alignment, and it's going to cause all kinds of problems. So it is definitely something important to keep in mind. So I'm going to leave that at 2.5. Plunge rate is also important. 0.5, it's almost always set at 0.5 of an inch. So just 1/2 of an inch per second is when the bit is going to be plunging through your material. I've tried messing with that before, taking that up to 1.5, and it's caused problems. It's knocked my Z out of alignment. So leave that at 0.5 of an inch until you get more experience and know what you're doing. Tool number does not mean anything. Once again, that's another feature that some more expensive machines actually have a whole bank of tools that it'll change itself it'll execute one tool path that needs a 1/4 inch bit, and if the next tool path needs a 1/2 inch roundover bit, you can name that 1/2 inch roundover bit tool 2, and it'll stop executing that code. It'll go over and grab the bit, it'll install it, and then it'll keep going down the line. That is a very expensive machine. We don't have that. You can name the tool number whatever you want. It does not matter. We have them every single different tool path. You have to manually load in. It's not that difficult. It's not difficult at all. But just keep in mind, tool number means nothing to us on our machine. If you go to a nicer, I hate saying nicer, our machine is nice, but more expensive machine that has that feature, you might have to remember the different tool numbers and things like that. So that looks good. We're fine. I'm going to press OK. Go ahead.
The diameter part, is that the shank that you install in
Nope.
the router, or that's the size of
Yep.
the
Let's go back to that. I'm going to go back to my edit, and it shows you right here. Well, that's not right either, because not always I think that what I'm going to go to select instead of edit, and if I go to a V groove bit here, see it changed. The diameter is completely different. The diameter, well, with a V groove bit, it actually, because you can have the diameter of the shank, the machine does not care at all.
So it's just the cutter.
It's just the cutter, absolutely. So yeah, you don't have to, with our machine, I don't really see why any machine would need to know the diameter of the shank. It needs to know the diameter of the actual cutting bit, because you'll have, just like this V-groove bit here, the actual cutting head is, the diameter is way wider than the shank. The shank is just the long part of the router bit. And those come in 1/4 inch, those come in 1/8 inch, 1/4 inch, 3/8, so on and so forth. Once again, the machine does not care about the diameter of the shank. It does care about the diameter of the cutter head. So when it says when you see diameter within this prompt, it's talking about the cutter head. And most of the time, with end mills, 1/4 inch end mills like this, 1/2 inch end mills, it'll be the exact same. Because if this was a 1/2 inch end mill, it would just be a full. It would be. There's no reason to have a 1/4 inch shank with a 1/2 inch cutter head on it like that. When it comes to end mills, when it comes to just a normal router bit that doesn't have these nice solid carbide spiral flutes, you might actually come across. And actually, I'll show one to you. It's a 1/4 inch shank. I actually have one that's got a full 1.5 inch cutter head with just a 1/4 inch shank. So it's just keep that in mind. The router bits come in all kinds of shapes and sizes. There's literally thousands upon thousands of them. But the diameter is in here is the cutter head, because the machine needs to know that. It needs to know how much material is going to be removed with that. So it actually is smart enough to know that that's now going to be a 1/4 inch groove. So it'll take that into account. And if I wanted to change, actually maybe I wanted a 1/2 inch straight bit to cut out that. Maybe that's all I had. I didn't have a 1/4 inch bit to cut out this profile, but I had a 1/2 inch bit. I can just go to select, and it already comes pre-loaded with tons of different router bits. And so you just select the one you have. If you can't find the one you have, it's probably never going to happen, but if you do find a bit that just you can't have, you can make a new bit. Just go down here and press new, and it'll give you all those prompts that you can dial in yourself. It's very, very easy. But we're going to change that to a 1/2 inch end mill. I got one right there. Just click it, and I have no idea why that says 0.49. It's kind of weird. So we got a full 1/2 inch router bit. Past depth for this, I would still want to leave it at 0.26. Step over means nothing. Once again, just for profile tool pass means nothing. And I'll take this back down to 2.5. Oof, definitely do not want a plunge rate of 1.5. Once again, plunge rate, leave that at 0.5. That was probably me. I was probably messing with something. If you would have came in fresh on a fresh default install, it would have been 1.5, so you probably wouldn't have had to mess with that. And now I have my 1/2 inch end mill if I want that. So select allows you to select whichever tool bit you want. Edit will just allow you to edit the bit you have in there. I can't change my bit. I want to go ahead and change it back to my 1/4 inch. Just verify. I actually want to go ahead and repeat that. 2.6, 2.5 feed rate. If I left that at 3, it'd be just fine. And now the important part is down here. After you select your bit, make sure all the speeds are good. I'm going to go ahead and stop this. The next section is, as you can see, this little picture here shows you exactly what it is. This little yellow ball here, that's your actual router bit. This little crosshair is where the bit started. And the square shape is your shape. So do you want the bit to be on the outside of that line? Or do you want it to be on the inside? Or do you want it to be right on? So those are very important. You can do different things. But also keep in mind that it remembers your last option. So if the last thing you were doing was cutting the inside shapes out, and you come back in and you don't pay attention to that, and you want the outside shapes, there's going to be a problem. You're going to accidentally cut the wrong side of the line. So definitely get in the habit of making sure you're cutting on the right side of the line. On the correct side. Hey, Alex. No. So definitely important. Make sure and just use that little guideline there to make sure you're on the right side of the line. And that's exactly what we want to do. Remember, we're just cutting outside the profile of this, so we do want outside right. The direction is important. If you watch that little picture there, if you change it from climb cut to conventional, it changes the direction. That's a whole big different discussion on which is better. what you need, which time you need to use a climb cut versus a conventional cut. It all depends on the router bit, all depends on what you're trying to achieve. Until you know better, just always leave it on conventional. It's not going to hurt anything. Allowance offset, leave that at 0. I've never messed with that. Use vector start points, never mess with that either. So I always leave those defaulted to off. Tabs, the next little buttons, options down here are very important. The tabs button, extremely important, because keep in mind, when we put our full 15 by 15 piece of plywood onto the CNC machine, what we're going to do, since we have a lot of scrap wood, we're going to screw it down to our spoil board here in the 4 corners to adhere it to our table. And then what we're doing now is creating the profile toolpath that is going to cut this shape out. Once we cut this out, if we fully cut it all the way out, it's going to be loose. It's no longer going to be attached to the table unless we want to put a screw in the middle of our sign, which we don't want, obviously. So we need something to still hold this onto our piece of wood while it's cutting. Otherwise, as the router bit is coming around and removing the material, as soon as there's no more material holding this in, even though you would think it would just kind of be floating in there, wouldn't hurt anything, vast majority of the time it's actually going to kick out, it's going to cause some problems, it's going to, the piece of wood is going to slightly shift, and it's going to dig into your router bit, and it's going to cause problems, it's going to ruin your piece. So you always want some way to, if you're cutting a piece out, it has to be adhered to the surrounding piece at least a little bit, and that's where tabs come in. Tabs are very important. Tabs are now, you're going to be able to create little tabs that hold the piece of wood that the machine doesn't cut out, that holds it there. So I'm just going to click on Add Tabs. The length you can change if you want. 1/2 of an inch is good. Thickness, that's good. You can put it at 1/8 of an inch if you want, 1/4 of an inch if you want, whatever you want. I'm going to leave it at 0.15 of an inch. I don't like 3D tabs. I don't think they hold very well, so I always leave that off. And then click Edit Tabs. Now, if I left it like this, or if I just change, I can change that to 4 or 10. If I really want to hold this on, and then I press Add Tabs. As you can see, it adds tabs automatically for me. It spaces them out perfectly for me. If I took that back down to 4, it'll just add 4. And it did it really with this nice even shape. It spaced them out really perfectly. If I said 0, it would do, well, adds 1. But if you just want to manually do them, all you got to do is click. And you can manually add tabs wherever you want. If you don't like where one is at, click and drag it. And you can move them around. So this is great for if you have awkward shapes, you can manually move tabs around wherever you want. So for this kind of shape, 4 is great. I'm happy with that. If you accidentally click a tab, like, oh crap, I didn't want that, just click it again, and it removes it. So there's different options to create tabs. Once you have your tabs where you want them, just press close, and those are still there. So fantastic, that's great. I'll be able to show you exactly what that's going to look like. Leads and ramps are important also. Get in the habit of using leads and ramps. Definitely recommend it. It makes a much nicer cut. A lead, add lead. We're going to click on that. And if you look at the picture, at the little curvature here, this long line is actually our profile line. That's what we want to cut out. This little curve line is where it's going to start coming in and out. So the machine, imagine my cursor is the router bit. If I didn't have a lead in, it would plunge directly down on the left on this side of the bit on the line and go around it. And sometimes that's okay, but just get in the habit of using a lead in because it really helps out. And what it's going to do, it's this right here, 0.0625. That's a 1/16 of an inch. It's going to start a 1/16 of an inch outside that line, then plunge down, and then it's minuscule. It's only a 1/16 of an inch. Then it's going to come in perfectly to that edge, and it does create a little. Because sometimes if you plunge down right on that edge, just the material and the router bit, there's just some physics going on there that it makes the router bit flex in a tiny little bit, where right where it plunged down, it's not going to be perfectly clean. So there's going to be a little divot where it plunged down. So a lead-in, that's the whole reason for that, is it gets rid of that little divot right where it plunged. Did you have a question?
Yeah. So would you use that on both kinds of cuts, like even for a pocket cut as well? Because, I mean,
Yeah.
it would
Why not?
Could it affect the design if it's cutting extra, right?
That's why, yeah. Well, that's why it's very small. It's only a 1/16 of an inch. I don't see how it could affect the design. I think if that lead-in, that little 1/16 of an inch, was going to interfere, if it was overlapping another line, it would. I'm assuming I'd be very surprised if it didn't give you a warning, or if it just didn't allow you at all. If that lead-in was going to hurt something, it probably wouldn't let you. So that's perfect. That's going to help us out a little bit. It's a tiny little thing, but believe me, it does help a little bit. So that's great. Just leave. If you want a bigger lead-in, you can change it, but 1/16 of an inch is good. A ramp is also very important and very handy. So we're going to click on ramps, and we're going to click on the Add Ramps to Toolpath. A ramp is very similar to a lead-in, except now it's actually in the Z direction. So instead of the router bit coming to its start position in the X and Y, and then it's going to plunge in the Z direction, without a ramp, it's going to just plunge right down, straight down, 1/4 of an inch, since that's what we have it set at. A 1/4 inch, probably not a big deal. But if you go any deeper, it's the exact same thing. Taking out that much material might make the bit flex a little bit, and it'll leave a little divot in your line. So the ramp, it'll come over, and as it starts on just toolpath, instead of just diving straight down in the Z direction and then moving in the X and Y direction, it'll slowly ramp down into the Z direction while it's moving in the X and Y. So it creates a little shallow ramp down into your toolpath, and it's smart enough to know that it's going to overlap that ramp and fully cut it out. So it just creates a much smoother entry into the wood. And once again, it sounds silly, but it really does help out. So it doesn't hurt anything. It might be adding seconds to your toolpath time, but in the long run, it'll make your bits last longer. It'll make your X, Y, Z coordinates not jump out of whack if you're removing too much wood. So I definitely, and it's very easy. Just leave it. You don't have to mess with any of these settings. Just leave it all kind of. If you're messing with a really small part, if I was only doing a 2-inch cutout, 3-inch ramp is a little too much. I'd probably change that to an inch. But other than that, 3-inch distance, angle, I never leave it at an angle. I just have the distance on there. So 3 inches is good, and it just makes a smoother tab, and it'll make your life down the line much easier. But that's it. Order and corners, I've never messed with, so feel free to mess with those, but they're pretty situational. Tabs, yes. Leads, yes. Ramps, yes. Ramps and leads, not going to kill you if you don't have it. For the longest time, I didn't use them, but now that I am using them, I'm very happy with them. Tabs, extremely important. If you're cutting out a piece, have to have tabs, or a screw holding that piece of wood down. So, got to keep that in mind. If you're fully cutting the piece out, it has to still be adhered some way, somehow. So that's good. We got everything set up, and now we're ready to name whatever that profile is, that toolpath. So we can say, name whatever you want. I'm going to say sign outside profile. And I typically, especially if I have a lot of parts, I'll name exactly what it is, and then I'll just say full cutout. And that way, if for whatever reason I forgot to screw something down, and I'm loading up this part file, this toolpath, on the CNC machine, and I see full cutout, I'm like, oh wait, I don't have a screw there. That's going to pop out and screw stuff up. It's just another safety net for me. And then I'm just going to press calculate. And it throws me a warning, and you are going to see this warning a lot. And all it's saying is, hey, you're cutting through your material. You know this, right? And that's okay. We want that. We actually want to make sure that we're cutting through our material for our purposes, since we want to actually remove this piece of wood. And that's all this warning is. It's just saying, hey, your toolpath is going to cut through your piece of wood. So that's no problem at all. Press OK, and then the 3D view comes up. And now I'm just using my left mouse button to rotate around. Now I can actually preview this and make sure everything's fine. And I'm going to scroll down just a little bit. And this is the projected path, the blue line. It hasn't cut through anything yet. It's just projecting the path for me. Yeah, go ahead, man.
You're at 11.
Oh, thank you. Yeah, so the blue line is the projected actual cutting out of the tool path. The red line, as you see, it's kind of important to pay attention to where that is, because that's kind of where it's jogging. It's not cutting anything out, but it's going to start here, and it's going to jog up here, and that's where it's going to plunge in the Z direction and then start cutting. If you notice that your red line is way down here or way over here, that's probably bad news, because that's where it thinks the Z coordinates are. So we're actually going to preview this toolpath. We already have it selected up here. This is your toolpath list. If you have a bunch of them, they'll be up here. So I'm going to select that and then just press Preview Toolpath. And that's all it did. Just showed it to you. And if you zoom in with the middle mouse button or the middle scroll wheel, you can actually visually inspect it. And I highly recommend doing this. It actually is a very good representation, if you've dialed everything in, of exactly what it's going to look like. So you can see your little tabs where it left them. You can see this is because of the ramping and the lead-in. That's okay. It's still, if I really wanted to, which I guess this is a good example I'm going to move that tab over a little bit to the right, because I don't like that my ramp and lead-in messed it up a little bit. So I'm going to go ahead and another quirk. This is definitely, well, it's not a quirk. It's actually probably a feature. But if I wanted to preview that again for whatever reason, well, it did it, but it didn't reset my 3D view. You're always going to have to get in the habit of going down here to reset preview and then doing it again if you ever want to see it again. And you can do it in slow motion too. Instead of pressing preview toolpath, you can just single step through it. And then there's lots of little steps. So, so remember, you're going to have to get into the habit of pressing that reset preview every time you make a change and want to visually inspect that change. So we're going to go ahead and move this upper tab a little bit just to show you that you can change all these things. So I'm going to reset my preview first. I'm going to close out of this preview box. I'm going to go back to my 2D view. I wish it would default back to my 2D view, but it doesn't. So remember these two tabs up here. You got your 2D view and your 3D view. So I'm going to go my 2D view. I'm going to go right back into the same toolpath that I have. So select it, go down here to Edit Toolpath. So everything is still saved. It's all there. All I want to change is that one tab. So just go down to Edit Tabs and move it over a little bit and close it. Go back down here and then just you have to calculate it again since you changed it. It's going to throw that same exact warning, which is okay. And then reset my preview again just in case. And now preview that toolpath again. If I zoom in, as you can see, now my tab is fully there, so I'm not, I don't have a weak tab up there. So I'm going to close that. I'm going to reset my preview first, close that, go back to my 2D view. So I'm happy with that. That's fantastic. I got my full shape cut out. Obviously, it's going to require it. Here, I'm doing all this and not showing you. If I want to preview that toolpath again without going into that toolpath and calculating it again, all you got to do is go down here to Preview Toolpaths, and that same little section of boxes pop up, and I can select my toolpath and Preview Toolpath. So obviously, once we cut this out, there's going to be a little bit of manual labor involved of fully cutting these tabs out and smoothing it. It is what it is. It's still a whole lot better than having to cut out the shape by hand. So you will, once we unscrew this full piece, we're going to have to cut out these little tabs and take it to the other tools and smooth it out a little bit. So do keep that in mind. So reset preview, close out of that, go to my 2D view. So now we're ready to do the inlay on the lettering. So just going to go ahead and select the lettering now. You have to select the vector when you make a toolpath. and we're going to use the V-carve. V-carve is a special toolpath that, remember when we talked about 2.5D, saying it was like a calligraphy brush? So it's not just moving in the X and Y. It actually is going to plunge down a little bit in the Z direction as it's moving to create that wider line and skinnier line. And if we zoom in on this lettering, as you can see, it's not the letters are thinner and then wider. The O here is nice and wide here, but thin up here. The V-carve toolpath is perfect for this, because what it's going to do, it's going to set its own imaginary center point on the center of these two lines. On the center of the outside two lines is what I mean. So it's going to do a invisible line down the center, and it's going to start here, and it's going to raise the bit, the little V bit we're going to do, into the two edges of the V bit are touching the two edges of the letter here. But then as we go out here, it gets wider, so it's going to plunge down until the two edges are touching the two edges of the letter, so on and so forth, where you get that thin and thick lettering. If we did just a normal quick engrave, which I'll go ahead and I'll show you the difference real quick. So we'll do the quick engrave first, and it has a couple different options. We're just going to do the outline, where it's just going to go directly on top of the line. Or we could do a fill, where it's going to take forever, but it'll actually try and hollow out all the inside of this with a little V-groove bit. So we'll do an outline first. Obviously, we want to pick our bit, so we're going to go to select. I think I already have that's the bit we're going to use. It's a 60-degree bit. You do got to keep in mind, V-groove bits do come in 90-degree bits also. So make sure you change this angle accordingly, because it will 100% change the outcome of your design. So we are using a 60-degree bit. Pass depth, 0.2 is good, because remember, this is just for engraving. We're not going down deep at all. 3 inches per second is great. Spindle speed does not matter. Remember that once again. A plunge rate, 0.5 is great. So we're just going to leave all that. My depth pressure, that's how deep you want to go. That's what that should. I wish it would just, I guess it says depth. But that's how deep you want to go. We only want to go down a 1/16 of an inch. So if we wanted to change that for whatever reason, you could. We're going to leave it at 1/16 of an inch. And so I'm going to just go ahead and leave it as quick engrave and press calculate. And there it shows you the actual, if you zoom in a little bit, these little arrows actually show you this little point is where it's going to come in, where the bit's going to come in, and the arrows show you the direction of the bit. Close that. It's very strange. I'm going to go back into that toolpath. Remember, select it, and then go to Edit Toolpath. When I created the Profile toolpath, when I calculated it, the 3D window popped up, and it allowed me to preview it. For some silly reason, it doesn't do that with this. I have to manually close out of this, and then go to my Preview Toolpaths button. Now, it's already got it selected, so you can select the different toolpaths you want to see. Let's go ahead and preview the outside full cut, the profile cut we did. So great. Now we're going to select my quick engrave and preview that toolpath, and it shows you right there. And once again, it just showed you right on top. It just went right on top of that line, 1/16 of an inch deep. The lines aren't any different in depth. It's just 1/16 of an inch the entire way. If that's the look you're going for, fantastic. I'm going to go ahead and reset my preview. Close out of here. Go back to my 2D view. I'll make a new toolpath. So that's the quick engrave. I'm going to create a new toolpath, but I'm going to keep that text selected, and then go back to that quick engrave, but then do the fill, just to show you the difference. Step over is, and remember, we're trying to fill this, so it's going to be hollowing out. It's almost like a pocket cut. It's going to be hollowing out the inside of these shapes. So the step over is how smooth do you want the bottom of that. And keep in mind, we got a little V-groove bit, so you're going to have to go really, if you want a smooth bottom, you're going to have to be stepping over just a tiny little bit, and it's going to take forever. With a little sign like this, it shouldn't take too much time, but we're going to leave that at the default of 0.01. And you can change the offset As you can see, the little picture shows you how it's going to be, or hatch. We're going to leave it at hatch. You can mess with these if you want to, but I'm just going to change this to quick engrave fill, and then calculate that. And once again, I got to close that, then go to my preview toolpaths. And now, if I preview that toolpath, see, it took a bit longer. If we zoom in, we got a nice. It's not a smooth bottom. You're never going to get a smooth bottom with a little V-groove bit, but maybe that's what you want. You like that kind of a cross-hatched look, and it's fantastic, and you're happy with that. Awesome. If you ever get crazy out of whack and you're trying to get back up here in the up top right, you can just click these buttons, and it automatically lines it for you. So if you ever get crazy, just default it back up there. So you got that option. We're going to go ahead and reset that preview. If we want to see the outside with it too, once again, you can always preview that toolpath so you can see the exact sign, how it's going to be. But we're going to reset it, close, go to my 2D view, and do the final quick engrave, which is what we're going to do. So we're going to select that text again. Now we're going to use the V-carve toolpath. And this is the 2.5D dimension toolpath. So the depth pressure on this, which is the flat depth here, is going to be a little different. You got to keep in mind this toolpath is smart enough to know, okay, I got a 60-degree bit. I'm only going to go down far enough until I touch the outside lines of this. If I only had this set at a 1/16 of an inch, so 0.0625, this is a 1/16 of an inch. What if with a 60-degree bit, a 1/16 of an inch wasn't deep enough to touch these two lines? It wouldn't perfectly match. So with the V-carve, you can say whatever you want. I can say an inch on this. It's smart enough to know that it's going to stop when it hits these vectors, and I'll demonstrate that. I don't recommend an inch, but you get the gist. I'm going to put it at 0.25, quarter of an inch. My bit is already selected. I got a 60-degree V-bit. If I wanted to change that, I could. I'm not using any of these things. So it's very simple. That's the great thing about the V-carve. V-carve, I'm going to just name this engraving. And then calculate it. And as you can see, the toolpath, it's right in the center. It's not doing the outline, it's not doing anything. So if I press preview toolpath, that's what it does. I'm going to go ahead and do the outside profile just so we can get a full preview of the actual shape. If I zoom in, it created nice, thick, thin, deep, shallow lines for me automatically, and it knew to stop right when it hit the edges of my vector. So it's a very handy toolpath, and it creates a nice, nice, pretty shape that I like. But I showed you the different options for the different ones if you like that better. 13 minutes.
So you were saying that if you have on a V-carve path,
yep,
if it's too small, it will still do like the thickest line to.
Yeah, let's demonstrate that. Let's take our. I'm going to go back into my V-carve toolpath. I'm going to go ahead and edit it, but I'm going to change my depth to a really shallow depth of. Yeah, probably 1/16 of an inch is definitely shallow, so 0.0625. For typical engraving, if you weren't using a V-carve bit, a 1/16 of an inch would probably be pretty good. But let's put a 0 in there. Now let's go ahead and recalculate that. I'm going to once see it has the leftover. You have to reset your preview, and now we're going to preview that toolpath. That doesn't look right. Well, let's see what happens. What just happened? Let's go back up here. So V-carve, edit, font depth, 0, V-carve, didn't use that, didn't use that. Calculate. That is very strange. Maybe that's a feature when it's that it knows what you're trying to do. And since you're not, it knows that if it does its normal V groove depth, it's not going to hit the outside lines of your vector, so it automatically defaults to doing a fill pass. Now that could be complete BS, or it could be a feature that we just don't know. But in essence, all that did is now it did a quick engrave fill because it was too small. Yep. Yeah, it's very surprising. Alright, so I'm going to take that back. I'm going to close this, go back to my 2D view, select my V-carve engraving. That's the one we're going to use, and I'm going to actually delete these other two. Very easy, just select it and delete toolpath. So I'm going to select that one, edit toolpath. I'm going to change that back to 0.25. And just to show you, I'll set it at 1. And then still got my 60-degree bit selected. Press calculate, press preview toolpath, and it's the exact same thing. So great. And if you have a bunch of toolpaths and you don't want to select preview all toolpaths would do it all. So you have that option also. So I'm happy with that. That's fantastic. It's the simplest sign in the world, but it'll work for us. What are we doing on time? What time is that? I can't see my little screen. Okay, cool. Yeah, it's about time to now save these toolpaths out and take it to the machine and show you how to set it up. So it's very simple. We're going to take our flash drive, just any thumb drive, USB thumb drive. We're going to pop it into our machine, our laptop or our desktop, whichever we're running PartWorks on, and then we're going to go over and have to save out the toolpaths. And to do that, you just select the different toolpaths. We got to get out of our preview screen here, so close our preview screen. Go back to, I just like my 2D view a little bit better. Select each toolpath individually, very important, and then go to Save Toolpath. Some CNC machines will allow you, if you have 10 toolpaths, you can select them all and create one file. And it will go, and you can load that one file, and it will, even if there's a tool change, it knows to pause, and a little pop-up screen will come on the computer over there and say there's a tool change, press enter when the new tool has been entered and zeroed. And you can continue on down the line with just one toolpath. You cannot do that with our machine. Each toolpath has to be completely loaded in separately, and it is very, very easy. It's not, you know, having it as one file might save you seconds, so that's not that big of a deal, but you do have to load them all separately and save them separately. So once you select it, press save, just go down to save toolpath. Make sure your post processor, all that means is what machine are you going to run it on, and once you select this drop down box, you'll see there are a lot of different machines that you can save out to. And if for whatever reason that does not say the right thing anymore, you're looking for .sbp ShopBot inch. If you ever do anything 3D, you want ShopBot arcs inch. That will be 3-dimensional carving. So those are the two that you're going to be using. It'll almost always be just defaulted to inch, but just in case, that's the one you want. And then save your toolpath. And it's as simple as just pointing to your thumb drive, or if you have another folder that you want to save it to first, just make sure you know where to find it, and name it whatever you want. As you see, it automatically defaults to what you named it before, and then save it. Put it on your thumb drive. So we're going to go to, I'm going to save it to my desktop right now. Put a new folder, thumb drive, save it in there, save, select the other one, do the exact same thing, save those out. Save them all in the exact same spot, and since we only have two small ones, it was very simple. I'm going to go to my desktop, I'm going to go to my thumb drive folder, and they're right there. .sbp files, these are the toolpath files. The ShopBot reads these files and knows that it's expecting a 1/4 inch bit and it's expecting a 60-degree V-groove bit, all the information regarding the speed rate, the vector size, everything. And we've done everything. All we got to do is go to the machine now, put our piece of material onto the machine, secure it, put our router bit in it, 0 the X, Y, and Z coordinates, and then load this file and press play. It's as simple as that. So we're going to go to the machine now.
Yeah, like 4x6 sheets or something. That's what I'm hung up on now.
All right, we're good.
You recording?
Yep. Okay, well, once you come over to the CNC machine, you're going to need to load up the program. And the program we want, as you can see, our desktop here is kind of loaded with a bunch of crap. But we want ShopBot 3, right here. That is the program that controls the CNC machine. And if you ever come to this computer to work on PartWorks, which is the design aspect, that's over here too. PartWorks, and you want PartWorks 2.5 down here. You don't want PartWorks 3D. So PartWorks 2.5D was just like the program I showed you we've been working on. So you just double click that and it's now interfaced directly to the CNC machine. So always the first thing I want to do is reset the actual machine. So I'm going to go over to the power switch and just turn it off, turn it back on real quick. Are you going to come over here? You don't have to if you don't want to. Say when.
Yeah, we're gone.
Okay, cool. So yeah, just always a good idea to turn it off and on. There's just this big red switch right here. So turn it off, turn it right back on. That's it. It'll save you a lot of headache down the line. Save you a lot of headache down the line. So this is it. The main, worker of this is just this little bit right here. This is the router. Everything else is the CNC. And that's all it is. It has these different rails that control it on the, this is the Y. Remember, the short area is the Y. The long area is the X. So that's it. Just moves it around and comes up and down also. And remember I talked about the spindle speeds? This is how you change the different spindle speeds. So all the way from 10,000 RPMs up to 21,000 RPMs. For wood, you would never ever go above 13,000 RPMs. So that's the bottom two slowest speeds. Anywhere around there, I'm almost always at 13,000 RPMs, so you'll be fine anywhere around there. And this is the dust collector. We'll be turning that on later. So it comes all the way down here, and it's got this dust strip. We got to put the bit on first, our router bit, and our router bits, I'm going to show these to you real quick. Router bits come in all kinds of different shapes and sizes. We got the big, the solid carbide. This is a upcut bit, 2 spiral, 1/2 inch thick. We have kind of the same exact thing, just really small, solid carbide. I think this is an 1/8 of an inch upcut bit. Just all depends on what you're doing. And then you have the really specialized bits. Like that little smiley face I told you I 3D carved a long time ago. It took an hour and a half to do. That tiny little bit right there. So it's angled. As you can see, it's not actually straight down, so it comes down at an angle. And the very bottom of this is actually rounded over. So it's fantastic for doing very intricate carving. These are little bits, probably cost, you can get bits like this, or bits like this. This is a steel bit with carbide blades welded onto it, which works fantastic. This is a more of a traditional woodworking bit, but it works fantastic in this machine. Something like this, you can get at Lowe's for $15, $20 max. This I had to order $75. So just keep in mind, there are bits ranging crazy prices. A bit I love, which I highly, if you're ever going to be cutting anything out of 3/4 inch plywood, highly recommend buying one of these bits. It's been well used. So, but this is a compression bit. And we're not going to be using this today, but I always tell people about these because they'll save you a lot of time. This is actually a spiral bit, but as you'll look at this and you see that it actually changes directions on the bottom quarter-inch of the bit. You can actually cut through 3/4 inch plywood in one pass at 3 inches per second without any tabs. So that down here like this, the spirals on top force the wood chips to stay down. The spiral changes in the bottom, which forces all the sawdust to stay in the cut, and the actual sawdust holds the piece in there. You can do a 6-inch circle all the way through without a hold down, and the piece will not pop. So I highly recommend these bits. It is situational, but I'll cut that off, I guess. It's very freaky looking.
How much is this?
That's the thing. If you go to Woodcraft, you can find that bit for $110. You go to a website called BAM Carbide, B-A-M, BAM Carbide, $35. So we're going to use this typical, just 2 flute, straight cut, very standard 1/4 inch woodworking bit. This is what we're going to use for our profile. Remember, this is just going to go down 1/4 inch. And go down to full 1/2 inch and then cut it out. And on that last pass, it's actually going to go around and it's going to know that tab is there. It's going to come up, not cut the tab out. So we're going to use that for this. And for the engraving, we are going to use this little, very simple V-groove bit. And this is a 60 degree. I'll show you the 90 degree if we have one. I think this bit is kind of gnarly, but comes to a 60 degree. This actually comes to a perfect 90 degree. You can definitely use this, but you've got to make sure that you told the machine, or you told the program, that you use the 90 degree V-carving bit. So we're going to use these 2 different bits. I'll put all these away. Show you how to install it. So this little dust skirt down here, we have to attach our router bit to the bottom here. We can remove this dust skirt. It's actually just held on by magnets, so all you gotta do is grab it and pull it down a little bit. Comes off, and it goes on just as easy. Got magnets that hold it on. We have a very talented member here. He's a retired nuclear engineer, semi-retired. Smartest man I've ever met. He designed this, he built this all here. Did it all, just in a couple days. Very, very, very amazing guy. So we're gonna take that off. Now we need, there's nothing on here, we need the collar. Remember we talked about the different shank sizes? Remember we got the router bit itself, but then we have the shank that the router has to hold on to. Those are always over here. So you got 1/4 inch, all the way up to a 1/2 inch. So if you have a big wide 1/2 inch shank, just grab the corresponding collar. Those will always be right here. So you got to grab that. You can screw it on first. You don't have to put the bit in there. Just right below there. Just screw it on until it's hand tight. Don't tighten it down until you put the bit in. Put the bit in a little bit. Make sure you got at least a 1/2 inch up there. Probably get as much as you can while this cutter head's still out there. Then you got to tighten it down with the wrenches. The wrenches always live right here. 2 of them. Make sure you put them back when you're done. But there's exact same size, but there's just 2 nuts down there that you got to tighten down. And I'm not going to lie, it's not the easiest thing in the world to do. But you're going to have to get in there. And make sure they're fairly tight. bit. So I have my straight cutter in there now. We're going to do the profile first, and then we're going to have to change it to the V-groove bit afterwards. You got to keep in mind, if we had a more complicated job than this, it might actually matter which one to do first. We might have had to have done the engraving first before we did the straight cut. So keep in mind, you might have to plan out your bit selection and your toolpath operations a little more. Doesn't matter for us. We can do either one first. Especially since we have tabs that are going to hold our piece in there. It's okay to do this last. So
do the engraving first and then not do tabs? Or do you always need to have the tabs no matter what?
Oh, no matter what. Yep, absolutely. So put our dust skirt back on. Great, so we got our bit in there. Now it's time, we need to zero our machine. Right now I have no idea where the machine thinks X and Y and Z zero are. I don't care. But the first thing I always want to do is I want to go ahead and get my material and put it on the machine. I'm going to set my V-groove bit to the side. My material was right back here actually. I just went and grabbed a piece of scrap wood out of our scrap pile. This is just 1/2 inch thick plywood. I like that face. This face is a little better. This is my nicer face. This is, I'm not going to lie, this is pretty crappy wood, but it'll do for us. If I had a full sheet of plywood, I would bring that corner all the way right to that far edge. Because I wanted to get the full, because it can't really cut past this bed here. And as you can see, I talked about the spoil board earlier. This is the spoil board. As you can see, people had cut through it a little too much. Someone was creating a guitar path, and that's way too much. That's a full 1/4 of an inch. Absolutely no reason to do that. That was a mistake. I've done it. We're going to do it. No big deal. But remember, the goal is this right here. Very light. You know, no more like a 32nd of an inch. So very light to nothing. There's a very talented guy here that cuts acrylic. He has a ShopBot machine at the shop he works at. He works at Kosai actually. They have an identical machine. Acrylic, the plastic stuff has, you know, the plastic sticky stuff on the face and the back. He can dial it in so perfectly. He can even hear that. He can cut through the acrylic and leave the stickiness. Cut through it perfectly. So the goal is to eventually be able to cut perfectly through your material and not even be able to tell that you cut through the spoil board. But as you can see, it's no big deal if you dive into it, which we're actually going to cut into it a little bit too. So I could leave my piece of wood there and screw it down in the 4 corners. But since my piece is small enough, I can put it anywhere on this machine. And since I already know I'm going to have to zero it for the X and Y and Z, I'm just going to put it somewhere where there's not so many, you know, there's a billion different screw holes here, and it's getting a little too weak. So I'm going to move this out to the center a little bit just to save this area. And you can put it wherever you want. So I'm going to put it right here. I'm going to try and make sure it's kind of square to the edges. I don't want it cockeyed like that. If you really wanted to, you can get a tape measure and make sure you're perfectly away from the edge so you're nice and square. But since I know my piece of wood is so much bigger than my shape, I have plenty of room to dial this in a little bit. So that looks like it's nice and square to me. So now I'm just going to go ahead and screw it in. There's always drill guns here. You can pre-drill it if you want to. You don't have to. Some wood, you can just power right through the wood. I'm going to go ahead and pre-drill. There's screws here. You might have to bring your own screws. Just all depends. So I'm just going to grab a plug that interfaces with the computer to the CNC machine. Probably came unplugged. And there's a tiny little USB cord that goes into the computer, and I guarantee that just came unplugged a little bit. So I'll plug that in and see. I'm going to retry, see what happens. Okay, beautiful. So that's all that happened. So I need to manually control the gantry. I need to move it out of the way. And to do that, over here on this big control panel, there's a little yellow box, and it's the to move tool. And if you read that, you can press K. Also activate it with K. So you can just click on that, and this little keypad comes up, and you can control the machine with these keypads now. And you can move it up in the Z direction, move it down in the Z direction. Or you can actually use the keyboard, the arrow keys on the keyboard. And to move it up and down in the Z direction on the keyboard is page up, page down. So I'm going to move it away so I can get to my screws. That looks good. Come back over here. Now I can screw it down properly. Very important to make sure you fully suck down the piece of wood to the spoil board. Sometimes when you do that, even if you see the screw head touch the top of the wood, it still might be above it. And so you got to make sure, visually inspect all the way around that you are actually touching the spoil board everywhere. And if I had a really big warped piece of wood, maybe I might have to put more screws down. But for our purposes, I'm okay with that. Okay, get these out of the way. So our piece of wood is now adhered to the table. Now it's time to zero the coordinates for the machine. So the first thing I want to do is do the Z. So you have to come in here, escape, get out of that manual control, get in the habit of doing that. And I'm going to use the keyboard shortcut for the manual control, which is K. Brings up that exact same box. And I'm just, to zero the Z axis, I want to move the cutter head over my material somewhere. That's all I got to do. In the center, on the edge, doesn't matter. So just move it over to my material. I just want to make sure my cutter head is over top of my material somewhere. When you get out, now there's a really special program. There's a program that does this, the Z part, zeroing the Z, does it really well, very accurately, on the fly. Back in the day, you would have to get a dollar bill out or a piece of paper out and slowly lower the head until you couldn't move that piece of paper out anymore. And then you would know, okay, that's close enough. Now you don't have to do that. There's a tool or a little program that does it for you. You have to get out of the manual control before you do this. So to press escape, get out of there, and up here under cuts, go down to zero Z axis with zero plate. Very important. So, cuts, zero Z axis with zero plate. Like that. It'll run through its little routine, and it'll tell you, hit enter when you're above the plate. The plate is mounted on this. It's on a little slide right here. You grab this, the machine, it's wired all the way through here, all the way through the machine to the bit. When these two connect, it actually creates a circuit. If you actually watch, right here on the inputs, number 1 light should light up when I touch this to the bit. And that's what it does. The machine knows the exact thickness of this, so when it hits it, it'll automatically add this thickness to whatever it did, and now it'll zero it automatically. So all you gotta do, put it underneath it, press enter. Make sure you're gonna touch it. It'll go down real slow, touch. Okay, it'll go up, and it'll come down even slower, just to dial it in perfectly. That's it. It'll give you a little dialogue saying, great, you're zeroed. Remember to put the zero plate back. That's all you gotta do. Now your Z is perfectly zero to the top of this. If you eventually want to zero to the table, you just would do the opposite. Just put the zero plate down here and zero it to that. But once again, I definitely for now recommend putting your piece of wood up there first and zeroing to the top of that. So that's great, but now we do have to do the X and Y also. You have to do all 3. There's no super easy way to do the X and Y. You just have to manually use the manual controls to bring the bit where you want X and Y to be. So I'm going to press K, or I can press the little yellow box over here to bring up the manual controls. And for now, I'm just going to try and dial it in by eye real quick. But I'm going to have to get under there and see it a little better. That's actually why this entire contraption here was built. It was designed so you can swing this around, lower it, and get under here while you're using the arrow keys and see it a little bit easier. It's beautiful, but it doesn't work quite that well. So an easy way to do it, so you can see that bit a little bit, is go ahead and take this dust skirt off. So now I can see that bit a little better, and I can still, I like to lower my bit, and make sure you're not running into your wood, just so I can see a little bit better. Lower it a little bit more. And for our purposes, that looks good. The big thing to keep in mind, can I see your pen and paper real quick? So we zeroed our Z, our piece of wood, right there. Got our screws in there. This is Y. That's X. This is us. Right here. Our router bit, the perfect Z, or the perfect 0 for X and Y is right there. You want it on the outside corner. You want the edge. That's perfect. You don't need to be that perfect. But that's where you want your Z to be. So wherever that edge is, that's where you want your bit to be. But since we had so much room to play around with this, in almost all cases, you won't need to be that accurate. But the thing to keep in mind is it's not, over that edge or inside that edge. It's actually on the outside of that edge. So do just keep that in mind. Thank you very much. So I'm good with that. I'm going to, once again, I need to now, the machine, look, if you look up here, the machine thinks X and Y are right there. I don't want that. I want X and Y to read 0. So before I zero that, I once again get in the habit of getting out of the manual controls. For some reason, if you try to do any of these things while the manual control dialogue is open, it causes some problems. It causes bugs down the line. So whenever you do any other things, make sure you press escape to get out of that manual control. And then go to 0. 0 to axis X and Y. And boom. As you can see, that's where our coordinates are. Once again, 0. 0 to axis X and Y. Do not go to 0, 3, because you'll screw up your Z coordinates too. So just do your X and Y. So that's where our machine is. That's great. I'm going to go ahead and jog home just to make sure. That's always my last step. So I go for jog home. Now, if I really wanted to, I can get a tape measure out and make sure my Z is perfectly 1.5 inches above my material, which I can just look and see that it's really darn close. So I'm happy with that. So that's it. Our bit's in. Our material has been put on the ShopBot. Our X, Y, and Z have all been zeroed properly. The next step is to load in our part file, turn on our dust collector, and run it. So I already got my thumb drive installed into the machine. To load up a part file, it's as simple as going to cut part right here, or file, part file load. We always just go to cut part, go find your thumb drive. So I'm going to go to my computer, I'm going to double click on my thumb drive, I'm going to find where I saved it, which was my class toolpaths over here. And now those are the toolpaths we just made. So we got to make sure we choose the right one. I got the straight cut bit in there, so we're doing the full cutout. So that's the one I want to use. So select open. This always comes up. Never change anything in here until you know better. I've never changed anything. You start messing with things, bad things are going to happen. Just press enter through it. And now it's ready to go. The next step after pressing enter is the machine turns on and it starts cutting. So just make sure in your mind, like, okay, I'm good, bit's in there. Okay, great. This is always where I usually turn on the dust collector. Quick note about the dust collector. Power buttons are right there. You always want to make sure this is open. This has a really nice feature, so when you're at the end of this, when you're cleaning off the tool, you can actually close this, grab this, and use the same dust collector as a vacuum cleaner. But you do have to make sure to use the vacuum cleaner, this has to be closed. But to use the dust collector in the ShopBot, it has to be open. So we're going to turn it on. Oh, I forgot to put my dust skirt back on, so I'm going to put that back on. Simple as that. We got my speed set. Now this is typically the router on here has an on and off button. This is typically left on. It does have the feature that it'll turn on automatically for you. So yeah, it's almost always left on, and when I press enter, it will now interface and turn the machine on for me. So someone came by and for safety reasons, while they were probably changing the bit, turned it off just to be safe. But keep that in mind. If I would have left this off and pressed enter and wasn't paying attention, it would go through its tool path and start cutting. And without that bit turning, it would have dived into a piece of wood and probably snapped off your bit. So when you press enter after this screen and you don't hear it, you start seeing this move and it's not making a lot of noise, stop. And once again, the oh shit button is space bar. And even now, I've done this a lot of times, the very first 10 seconds of doing the cut, my hands are right here. Because if I'm getting a little too close to a screw, carbide is not harder than drywall screws. It will destroy your $50 bit immediately. So plan out your screw holes very, very well. I have ruined many bits because that's good enough, close enough. No, make sure you know exactly where your screw heads are. So once again, spacebar, the oh shit button. So make sure you got it turned on. Now we're all set, ready to go. I should be able to press enter. We all should be wearing eye protection. I apologize for that. And if you ever need ear protection is right behind Mike here. Help yourself if you ever need ear protection. Help yourself. But yep, that's it. It's cut all the way through, but our tabs are now holding this in really well. If you look through there, you can see the MDF spoil board shining through. But those 4 tabs really got it in there. So it's okay for me to now go and do my engraving path, knowing that that's in there pretty well. And as you saw when it first came in and cut, it kind of like zigzagged back a little bit. That's because of the ramp. Remember, it was a 3-inch ramp, so it had to do that little bit over 3 inches. That's all that was. And it just helped save the life of my bit, created a cleaner cut, but that's all that was. if I didn't have that ramp, it would have came over, went, and started straight from there.
But the ramp goes on the line.
Yeah, oh yeah, it'll
go
went.
straight, but it'll ramp in.
Even if it was a tiny little circle, if I had a 3-inch ramp, it would have went around that circle exactly on the line, slowly, finally, until it got through the ramp. So that's fantastic. I do now need to raise the router up and install the new bit for the engraving. I'm going to press K, the keyboard shortcut, to open up my manual tool or my manual head movement thing. Technical term, Just going to move it over to make it a little easier on myself. Move it up a little bit with page up. And that's good. Just going to remove my dust skirt. Grab my wrenches. And then loosen it up. There we go. Don't have to loosen this up all. I don't have to take it all the way out. Because I'm using the same collet. I just got to replace the feed root bit. So let's put the new bit in there. Tighten it back up. Put your wrench back. I'm going to go ahead and leave the dust skirt off because every single time you change bits, you have to re-zero the Z. Because I probably did not put that bit in the exact same spot as the other bit. So I have to every single time. I have to re-zero the Z. I don't have to re-zero the X and Y, just the Z. So I'm going to do the exact same thing I did before, which that looks like it's good enough. So I'm just going to run that same small program over the 0 Z-axis with the 0 plate, but once again I'm going to get out of the manual controls, press escape, go to cuts, go to 0 Z-axis with 0 plate. It's going to ask me to press enter when I'm ready, so I'm going to run over here real quick. I'm going to press enter, grab my plate, put it underneath. Perfect. Put my 0 plate back. Put my dust skirt back on. Since I don't have to do the X and Y anymore, I'm good to go. I'm going to go ahead and turn my power back on, but keep in mind that's not actually going to turn it on until I execute my program. And I'm going to jog it home. I always get in the habit of jogging home just to make sure nothing got out of whack. So go to jog, jog home. Looks good to me. So I've got my thumb drive in there. I'm just going to load up my other part file. So cut part, I'm going to do the V carve engraving toolpath now. So I'm just going to double click on that. That same little box comes up that I don't want to mess with. So just press enter through that. Now it's going to turn on. If I press OK, I'm going to turn my dust collector on first. And then run it. head out of the way. And that's it. Grab the screw gun, unscrew it. And as you can see, it still did a really good job. You know, you can imagine if this was solid wood, you wouldn't see the plywood layers, and it'd be really nice. And you can fill that in with, you know, a different color or some different color epoxy and make it look really nice. But obviously, you're going to have to do another step because the tabs are still holding that piece in. But luckily, we have all the different tools here. You can use a bandsaw, you can use a jigsaw, you can use a handsaw, you can use chisel and a hammer. Whatever way that you need to get this piece of wood away from the scrap. You even take it to our edge sander and send it nice and smooth to the edge. Take it to the router table to route a nice profile around this edge. Heck, you could have done it on this too. But yeah, that's the basics of this. Makes signage is really, really easy to do on the ShopBot. But that's about it. Obviously, when you're finished, the default position of when you leave, the default position of this should be somewhere over here where someone can reach it. And your bit should be out of there, and the collet should be out of there. There shouldn't be anything in there. It should be ready for the next person. Just make sure you put the collet back, and make sure you clean up after yourself. Once you're done, there should be no sawdust on this. There should be no sawdust. If you're doing a big piece of wood, you're going to get sawdust, even with this nice dust collector. You're going to get sawdust everywhere. Clean up underneath, vacuum, just clean up after yourself, pretty much. But that's it. And once you're done, you don't have to turn the machine off. You don't have to turn the computer off. Make sure you take your thumb drive with you. I forget my thumb drive here all the time. But don't forget it. And that is it. So, questions, comments, concerns?
Is there, like, can you get the ShopBot manual?